This video is going to be over the distance formula. The distance formula. In this lesson you will be learning how to find the distance of a line or the distance between 2 points when given the xy coordinates. Well, let's review a few things. First of all, this is a coordinate plane, and remember our y-axis is vertical and our x-axis is horizontal. Our coordinates, our quadrants go starting with 1 and then goes to the left, so 1, 2, 3, and 4, and the origin starts here at the 0, 0. Now remember, to find a point on a coordinate plane, it's an xy point, so x, y, so you find the number on the x-axis first and then the y-axis, so you're going to go over first and up or down second. So it's either right or left first and then up or down second. So that's how you find a point on a coordinate plane. So if I wanted to find the point 2, -4. If I wanted to find 2, -4, remember I would go over 2 because it's positive, so over 2, and then down -4 because it's a negative, so 1, 2, 3, 4. So here's my point, 2, -4. That's just a little review. The next thing we need to learn before we do the distance formula is we need to review or learn square roots. Well, this is the symbol for square root. Okay, it looks like it's called a radical sign. Okay, it's called a radical sign, which is right here. It is used to express a root. A root is one of 2 or more equal factors of a number. So we have things called perfect squares, which means there are 2 numbers that are multiplied together that equal that number. So the square root of 144 is 12 because 12 times 12 is 24. So there are many perfect squares, and if a number times itself, so 12 times 12, if there is one number that multiplied together equals the number under the radical sign, that means it's a perfect square, and it's going to end up being a whole number, okay, without a decimal. Now we have non-perfect squares. Non-perfect squares are squares that are irrational because they have decimals that never end. So these decimal numbers will never end. So and it does not repeat. So a non-perfect square is a decimal number. So a perfect square, no decimal. Non-perfect square is a decimal number. Now, to find a square root on your calculator, which you need to do because doing it in your head or mathematically is very difficult. So the first thing you need to do, this is the OGT calculator, you would need to hit the second button first, then the x squared button, and then 49. So you would enter second, the x squared button, and 49. And you can see here I have the x squared button, and right here blown up. If you see on top of this x squared button, you see the square root sign. Well, on the calculator it's in yellow. So all of these symbols that are in yellow are can be used by hitting the second yellow key first. So the second button means the inverse operation, and we've talked about that before. So the second button equals the inverse operation. And the inverse operation of squared is the square root. So just like the inverse operation of addition is subtraction, multiplication is division, the inverse operation of the squared button is the square root. So that's why it's on top of that button. So you're going to hit the inverse key, which is the second key, and then x squared to get the square root. On your screen it'll look like this. You'll hit second, x squared, and this will come up. Square root sign in a parenthesis. You will put in your number. You can close the parenthesis if you want with this parenthesis button, but you don't have to. And then hit equals down here, and you'll come up with the number 7. Alright, let's do a couple guided practice problems with our square root key. If you do not have your calculator in front of you, please push pause and go get it and come back. If you do, let's move on. Alright, it says on the number line below, which letter best represents the square root of 3? Well, the first thing we need to do is we need to find the square root of 3. So on your calculator, you're going to hit second x squared 3 equals. So do that now on your calculator. I'll give you a second. Okay, you should get 1.732050808. It's a big number. In most of the cases, you can round to the nearest hundredth, so you can get rid of all these numbers. So since this is a 2, that's going to stay the same, so it's 1.73. So on your number line, what letter is closest to 1.73? Well, this is about -3. Okay, this is less than 1, so we know it's not these two. This is over 1 but not quite 2, and this is what our number is, over 1 but not quite 2. So it should be C. Y is the closest to the square root of 3. Alright, let's try this. Find the square root of 27. Well, when you find the square root of 27 on your calculator, you're going to get a decimal number. And those answers down there don't look like decimal numbers. So what we need to do was we first need to find the square root of 27. Again, if you don't have your calculator, you need to go get it. Okay, to find the square root of 27, again, hit your second key and your x squared key. 27 equals, which you should get 5.19615 and so on. Okay, now to find which of these equals 5.19615, so and so and so on, you need to figure these out. So to do 3 and then the square root of 3, to figure that out, all you do on your calculator is type in the number 3 second x squared 3 equals 3 second x squared 3 equals, and then type in 3 second x squared 9 equals 9 second x squared 3 equals, and 2, whoops, and then second x squared 7 equals. And when you do that, you will get a whole bunch of decimal numbers for each one, and you need to figure out which one equals 5.196. Go ahead and do that, press pause, and then come back and see if you can figure out which letter is correct. Alright, now that you're back, the first one, 3 second x squared, 3 equals, that's how you figure out this right here, equals 5.19615, so on. So you didn't have to go very far to find the answer. So the answer is A. So even though those look very difficult, they're not difficult at all if you use your calculator. Very easy to do if you use your calculator. Alright, now we're going to move on to the distance formula. Now in this distance formula, it says you work on a road crew and your boss gives you 2 points, -2, 1, and 1, 5. And she wants you to find out how far apart they are. The points look like this. Well, you can't really count from here to here, okay? Like you can count from these points. So if I wanted to find the distance of this line, I would just count 1, 2, 3, 4. Or 1, 2, 3. Okay, but I cannot count to find my diagonal line. So this is where the distance formula comes into. Now on the distance formula, okay, you see that you have x squared here, and you have a y squared. You have an x1 and you have a y1. That means you need to pick the points that you want to be the first point and pick the point that you want to be the second point. Okay, most of the time I just do point 1, point 2. That's what I usually do. And so because I like to do that, you can either color code it or you can just put 1 and 2. You can do whatever you want. Sometimes I also like to teach kids to do this is x1, y1, x2, y2. So then when you're down here, you don't get confused. So now all we have to do is plug in our numbers to our variables. Okay? So everything is going to go under this radical sign every single time. Okay, so x2 is 1 minus x1, which is -2 squared, plus y2 is 5 minus y1 is 1 squared. Okay, the next step, so all we did was substitute those numbers in for the letters. Now our next step is we're going to do what's in parentheses first, because in our PEMDAS, our order of operations, parentheses is first. So 1 minus -2. Now if you don't know how to do this on your calculator, what you need to do is hit 1 minus the negative sign, which is right next to the decimal point, -2 equals. Okay, and you'll see that it equals 3, and then we have to put our squared button. Okay, plus 5 minus 1 is 4 squared. Now we have to do our math computation. Now, on our calculator, you will have a button. Let me move over here. You have a button right here. This is a caret key. Okay, and this caret key are for exponents. Okay, now you can either use this caret key or the x squared key. I always tend to use the caret key because you can use that for any exponent. The x squared key, you can only use it for squared numbers. So 3 squared, you would hit 3 caret 2 equals. Which equals 3 times 3, remember, which equals 9. Okay? Then for 4 squared, you would hit 4 squared, which equals 4 caret 2 equals, and you would get 16. Okay? So 3 squared is 9 plus 16. Okay, 16 plus 9 equals 25. Now we have to find the square root of 25. So to find the square root of 25, remember, you would do second x squared 25 equals second x squared 25 equals. Then you should get 5. So distance equals 5. So this line equals 5 units. Very simple. It looks very difficult, but it is not. It is very simple. Let's go on to the next one. Alright, we have -1 and 7 and 3 and 4. So this is our x1, y1, x2, y2. So now all we're going to do is substitute those numbers in for the letters. x2 is 3 minus x1 is negative 1. y2, 4 minus y1, 7 squared. Let's do the math inside. 3 minus negative 1. Remember, on your calculator, to get the negative sign, it's by the decimal point. So hit 3 minus negative 1. You do not need to put the parentheses if you don't want to. Equals 4 squared plus 4 minus 7 negative 3 squared. Four squared, remember, is you go 4 caret 2 equals 16 plus negative 3 squared. So you're going to hit the negative sign, 3 caret 2. So negative 3 caret 2 which is negative 9. Which is a positive 9. If your calculator gives you a negative 9, that is incorrect because a negative times a negative will always equal a positive. So 16 plus 9 is 25. And in the last problem, we just found out that the square root of 25 equals 5. But you would do second x squared 25 equals. Hopefully this is getting easier. Now we'll do one more example here. Okay, this example, it says let's try to prove that two sides of a triangle are equal. Okay, so if we have this triangle, that's not what it looks like, but we're just going to hypothetically say A, B, and C. We want to see if AB and BC are equal, or AB and AC are equal, or BC and CA. We need to figure out if two sides are the same. So we're going to start with AB and BC, just because that's in order. Okay, so we're going to try to prove if these are equal. Alright, so to do that, we're going to use our distance formula. So we're going to do line AB first. Remember, this is x. I'm having some issues today. So x1 and y1, x2 and y2. Okay, so x2 is 4 minus x1 is 2 squared plus y2 is 9 minus y1 is 3 squared. 4 minus 2 is 2, then squared, plus 9 minus 3 is 6 squared. 2 times 2, or 2 to squared, would be 4, plus 6 squared is 36. 36 plus 4 is 40. Okay, so we have the square root of 40. And to find the square root of 40, you would hit second, x squared 40, and you get 6.3245, so on, so on. Okay, so now let's try BC. This would be x1, y1, because we're done with this other coordinate over here. So BC equals x2 is 4 minus x1 is negative 2 squared plus y2 9 minus y1 7 squared. 4 minus a negative 2. So remember, on your calculator you're going to go 4 minus the negative, which is by the point, 2, which is 6 squared, plus 9 minus 7 is 2 squared. 6 squared is 36, plus 2 squared is 4, and as you can see it's starting to look the same, the square root of 40. Well, we know they're the same without doing the math because they're both the square root of 40. So we just figured out, we just proved mathematically that AB is equal to BC. Okay, and if they say prove, all you need to do, you do not need to draw a picture, all you need to do is do it mathematically like we just did, and that proves mathematically that AB and BC are equal. Hopefully this has helped you understand the distance formula. If not, go through the written lesson or watch the video again. If you're still having problems, make sure you contact your teacher.